Hello, let's get on with problem 5. Gamma naught of P I believe that the cusps were naught and infinity. That was the result of problem 18 of section 3.1. Yeah. And again, applying problem 3, we have for naught, we have alpha equals s, and for infinity, we have alpha being the identity. That's s, the inverse of s, times t to the nth, or to the h, let's say h, and s. And the question is when this lies in gamma naught of P, and that's of course exactly when H divides P. So that means the ramification index of naught is P. I'll just write it in blue here. Infinity, that should be quite simple, because this lies in gamma naught of P for H being unity. So it has ramification index unity. All right, let's go to B. And here we have the cusps minus 1 divided by Kp. And I believe it was up to P minus 1. Yeah. Naught, that gives here, and it's immediately in the right. So it has ramification index unity. Infinity, it's this guy as well, and we need to have minus h, or that's h, lying in p squared, so it has ramification index p squared. P squared needs to divide h, the smallest one doing that. All right, now these should require some work. Let's how was it? Alpha to minus first should map them to infinity, and that means if we multiply them by Kp, we get minus 1, so adding 1 should put it to infinity. And then we need to complete it to a matrix of determinant 1. Call this x, y, then x minus kpy must give unity. Oh, that's really pretty simple. If we choose this to be 1, then this can maybe kp plus 1. So let's get kp plus 1 minus kp. Excellent. Let's see if this is the inverse. Kp plus 1, yep. Minus kp plus kp, yep. Minus kp plus, right, that works. That gives pretty long expressions. I'll just do it in Maple to be sure to get something sensible out of it. Oh, oh yeah. We should have defined GH up here to be this guy. There we go. Oh. That was somewhat longer than I anticipated. Oh, we used we need to define the inverse because it's, no, it should be able to simplify it. Ah, that's better. Ah, damn it. I can't copy it over and it disappears when I write it. Well, maybe we should not write it. It needs to lie in gamma naught of p squared. Well, this does already. That was shocking. My. So they already lie in gamma naught p squared. So that means they have ramification index unity. Surprise. All right. Then we can go to C. And here we have the ramification indices. Yeah, I forget them. It was naught and infinity, and then the other one was that -1. I need to check that. Yeah, -1. Infinity, that's of course 2. And naught, we already have the expression here, so that's 2 as well. Still a -1 lies in gamma 2, so it's regular, of course. -1 is the only one we need to check, or we could check unity, but let's check -1. Mapping -1 to infinity, that's like 1, 1. -1 times 1 gives -1 plus 1 vanishes. Just choose this guy. And that means alpha equals 1, 1, -1, naught. And let's do that in Maple as well. Let's define it to be B. It's safer. So for which A will this lie in gamma 2? It should when H is 2, shouldn't it? But it doesn't seem to. when h is naught, we are done. Oh yeah, when h is 2, then they are equal, and this is equivalent to unity. So -1 has ramification index 2 as well. Well, I was afraid this one would take quite a while, so that it could be solved so easily was quite a surprise, a pleasant surprise.